Hello, my name is Peggy Bloomer, Assistant Professor of Art and Design at Central Connecticut State University. This presentation is titled The Shape of Data: How Classification Constructs the Digital World. Today, I'll discuss how classification systems in machine learning and AI are not just technical tools, but cultural practices that shape what we know and how we act. Let's begin with John D. Norton's material theory of induction, which posits that inductive inferences must be locally grounded in empirically specific material conditions rather than governed by abstract or universal schemas. In conjunction with Simondon's theory of individuation and Hui's framework of cosmotechnics, this approach reveals classification as a contingent and co-constitutive process, one that emerges through relational ontogenesis rather than pre-existing taxonomies. Far from neutral, classificatory systems are materially embedded, socially encoded, and capable of reinforcing epistemic bias. Through case studies in predictive policing and AI training datasets, we examine how computational systems instantiate fixed ontologies that resist the metastable dynamics of social individuation as theorized by Simondon. Systems like predpol operationalize historical arrest data as stable indicators of future risk, disregarding the relational genesis and continuous transformation of social realities. From a cosmotechnical perspective, as outlined by Hui, these models universalize particular epistemologies, often Western, bureaucratic, and carceral, thus suppressing alternative modes of knowing and organizing. The result is an algorithmic infrastructure that not only encodes structural bias, but also forecloses the ontogenetic potential of data to reflect emergent locally situated complexities. From Aristotle's hylomorphism to Kant's categories, human understanding has long depended on classification as a way of imposing order on the world. However, when these rigid schemas are applied to social categories such as race, gender, or class, especially within algorithmic systems, they risk amplifying historical biases. This is particularly evident in the construction of training sets where pre-labeled data often reflect entrenched social inequalities. These data sets do not merely mirror reality, they shape it, embedding normative assumptions that algorithms then reproduce at scale. Simondon posits that individuation arises through transductive processes, continuous dynamic interactions between system and milieu, rather than from the instantiation of fixed essences or predefined types. Building on this, Hui critiques the ontology of digital objects structured by metadata schemas, arguing that such classifications are not ontologically neutral but emerge from and reinforce specific systemic contexts. In both frameworks, categorization is understood as materially embedded within evolving technosocial assemblages. Digital objects, as Hui articulates, are not discrete or static entities, but dynamically constituted through metadata regimes and contextual dependencies within distributed computational networks. His cosmotechnical critique foregrounds how classification systems, when treated as fixed ontologies, obscure the relational and contingent nature of digital entities. This becomes particularly problematic in machine learning pipelines, where models trained on correlational patterns within labeled data sets risk reifying spurious associations as causal structures, thereby embedding systemic bias into algorithmic decision-making. Classification systems function as active mediators that structure the epistemic and operational environments in which new data is generated, interpreted, and acted upon. Drawing on Simondon's concept of the associated milieu, it is clear that this process is a recursive coupling between system and environment, wherein the act of categorization co-produces the conditions of future individuation. In computational contexts, this dynamic is evident in feedback loops within algorithmic infrastructures, where prior classifications influence subsequent data collection, model training, and decision-making parameters. Simondon's concept of concretization describes the process by which technical objects evolve internal coherence through increasing integration of functions and adaptation to their environment. Applied to AI systems, this suggests that classification schemas should not remain static, but instead evolve in response to anomalies, edge cases, and shifts in the data landscape. Hui's work emphasizes that digital objects exist relationally and that classification must account for cultural variation, what he calls cosmotechnics. There is no one-size-fits-all classification system. Rather than blindly applying static, historically derived categories, classification systems must incorporate mechanisms for adaptive learning, probabilistic reasoning, and human-in-the-loop oversight. This includes modeling uncertainty through techniques such as confidence scoring, Bayesian inference, or ensemble methods, and enabling reflexive system design that supports iterative reevaluation of labels and taxonomies. Embedding reflexivity within the AI pipeline is essential to mitigating the propagation of historical bias and ensuring responsiveness to evolving social and epistemic contexts. Together, Norton, Simondon, and Hui offer a powerful framework for adaptive, ethical, and epistemically sound classification. Rather than rigid models, we need living systems capable of change, reflection, and justice.